everyone. My name is Sunny Kim from ReviewMind, which is a venture startup company providing review analytics service using the state-of-the-art AI NLP technology. Today, I'm going to talk about introduction to NLP and topic modeling. This is a little bit of details of today's talk. Then let's start. Okay, the first take, introduction to NLP. Nowadays, NLP, text analytics, and its related group of technologies are becoming a really hot topic because it has been through a lot of technical innovations and advancement, especially in recent years. Moreover, its technical demands in the real-world industry are also getting higher and higher. According to the industry lore, up to 80% of the information owned by large organizations is in the form of unstructured text documents. So then, what is NLP? The formal definition of NLP, following by Wikipedia, a subfield of linguistics, computer science, and artificial intelligence concerned with the interaction between computers and human language, in particular, how to program computers to process and analyze large amount of natural language data. To get a more simple understanding, I just can say that NLP is all about how do we get those text data and make them useful in a way to interact with computers and machines. Traditionally, this NLP area has been studied in many different departments, such as in computational linguistic departments, in computer science department, or speech recognition in electronic engineering, etc. But nowadays, it tends to be unified as a convergent technology, so you can see the product like Alexa or Google Nest. So in modern NLP field, people tend to divide the related terminology as NLP and NLU, and more high-end technology like ASR, automatic speech recognition, and TTS, which means text-to-speech technology. In this context, simply put, NLP is more related with the synthetic aspect of language analytic. Meanwhile, NLU is more related with the semantic aspect of language analytics. Next, let's see the applications of an NLP these days. There can be a lot of dynamic solutions for different real-world business scenario. The several of them here must be familiar with you already. Search engine and spam classification, maybe you are using them in your everyday life. Meanwhile, conversational agents like chatbot or automatic Q&A answering machines are getting more and more popular. The company like us, ReviewMind, we are focusing on semantic analytics on people's comments like review, social media, community posting. However, I think these technologies are still working on the baby step, especially in their application-wise, which means there still exists a lot of innovation points with intensive R&D process. So in here, you can check the technical maturity of each NLP task. For example, spell checking technology is quite mature in English, even though it depends on which language you are targeting at. Definitely for English, there are many options for spell checking, and they are quite great. Meanwhile, for Korean, there are a few options, and it's a long way to go to get to the decent maturity level. Meanwhile, machine translation is still at the early phase in general, as you already know and experience via Google Translator or etc. Okay, then let's go to the next session for NLP Basics, which is the very fundamental text handling technique for this is all about how to make for a computer to understand low text data. Maybe you have heard that the data processing phase is usually very time and labor consuming, but at the same time, very critical for the whole machine learning analytic process. and it is so in the NLP area with text data. It can involve many tedious but delicate procedures depending on what kind of model problem you're targeting. Text data preprocessing usually involves a sequential combination of various preprocessing steps depending on the problem domain and target model context. It can be roughly divided into two parts, as you see this diagram. The first text clean part is including identifying noise, removing those noise, character normalization, data masking, etc. Usually we identify punctuation, stopword, numbers as noise. However, depending on your target model problem, numbers can be a very important factor you should not remove. In other cases, in the semi-structured text documents like financial audit reports or a legal document form, those structured text template parts can be treated as a noise too, as you should remove. So like this, you had better carefully consider what kind of processes are necessary on your target domain, rather than apply a one universal combination of text preprocessing technique to all the situation. Character normalization, you change uppercase into lower cases, especially in English-like languages, because computers understand upper and lower differently, unlike human beings. Data masking, it's also important these days as personal information, such as phone number, addresses. Those are should be removed or data masking for their privacy protection. Sometimes this can be used for pre-phrasing issue in text analytics. And the other linguistic processing part include tokenization, stemming, or lemmatization, POS tagging, etc. These are the results to try to understand the text in more deep level. So in this session, we will discuss this general text preprocessing task one by one, and we'll see the example use cases with actual Python code using tools. So as a basic NLP preprocessing task, we will talk about tokenization, stemming and lemmatization, and removing punctuation and stopword, and part of speech tagging. Okay, before we go to the use cases of each text preprocessing task, let's talk about the tools to help us to handle this NLP task. There are many tools out there, but I would like to mention the most popular and representative tool, which is regular expression, NLTK, and Spacy. First of all, regular expression is a sequence of characters mainly used to find and replace patterns in a string or text. It is a very useful tool for cleaning and wrangling of text data. For practical purpose, I recommend you using text tester, regular expression tester. It's free and convenient to check the complex regular expression based on your target data set. Actual execution of regular expressions, you can simply use a Python built-in package. Its name is RE. This is the most commonly used tool in my real-world experience, real-world project, especially when you are necessary to do some delicate text preprocessing task. Let's check some use cases with regular expression. The most NLP preprocessing package, such as NLTK or Spacy, are also supporting punctuation remover function. But in my case, they were never enough in a real-world project somehow. So I had to handle some remaining erratic punctuation all the time using this regular expression. This Python code example show how to check the punctuations in Korean text data. So in these regular expressions rules, I try to find every characters except a word or space. The other use cases is telling you how your analysis domain can affect on your decisions on how you're gonna do the text preprocessing task. These are the special language usage of Koreans, very unique kind of language expressions, behavior to express their emotions using some punctuation characters. It's like something like emoji. Um, in this case, maybe I need to identify them separately using regular expression and treat them like their corresponding emoji or words. It relies on the decision of each data scientist. The next representative tools for NLP are NLTK and Spacy. Both of them are Python open source, commonly used. Spacy is an NLP library designed to effectively handle NLP tasks with the most efficient implementation of common algorithm. For many NLP tasks, Spacy only has one implementation method, choosing the most efficient algorithm currently available, which means you have no options to choose for your target NLP preprocessing task. Meanwhile, NLTK is a representative and traditional open source NLP toolkit initially released in 2001, which is much more older than Spacy. But NLTK provides many functionality, but include less efficient implementation, usually. The table of this slide is showing you the comparison of these two most well-known NLP tools. It's mentioning that NLTK is good for extensions with other languages or different approaches of each NLP task, while it's slow and a bit outdated for integrating with other NLP tools such as word vector. Spacy is the latest and the updated tool, while its lack of flexibility and limitations of supporting language is mentioned as its flaws. I personally have been watching many recent big movements of Spacy. They are very interesting. Other than their fast updating open NLP toolkit, Spacy keep launching their new products such as the integrated tool with transformer of Hugging Face or text annotation tools such as Prodigy. So I recommend you check their recent book. Book's name is The Mastering Spacy. Would be really helpful for your understanding and practicing of NLP text preprocessing task handling. Okay, then let's go back to the use cases of each text preprocessing task. The first of all, tokenization. Tokenization means dividing a continuous text into distinct units, such as sentences, phrases, or words. And this divided language unit can be a feature for the next computer analysis, like machine learning or deep learning. And it's usually a word in a real-world practice. In this example, the both of tools, NLTK and Spacy, have used white spaces and tokenizes a text into the word analysis unit. For stemming means cutting the inflected word into their root form. So all the verb or adjective or verb, past or verb presence word will be changes into their same root word. In this example, you can check the stemmed results of a few words like currently has been changes into current, and reading has been changed into read, and sticky has been changed into sticky, etc. Okay, the lemmatization means reducing the inflected form of a word into a single form for easy analysis. Often stemming and lemmatization is confusing. So in this case, in this example, maybe make it clear for you. So in stemming, lift and leaves would be conversions into each different word as leaf and leave exactly. respectively. But in the lematizations, all of these words go to the one word leaf. So it tries to make the word features into a more simple format by combining words into one root word in case they came from the same lemma. So it's a little bit hard to check the case in this example, as they are mostly similar between stemmed and lemmatized lizards here. But you can check here, please become ple plus s in stemmed lizards, but it became ple in the lemmatized lizard. Okay, next, the stop word, meaning the words can be considered a source of noise in our text data. Usually, it could be the prepositional words such as on, the, etc. So in this example, I have used the default English stop word from NLTK. The detailed stop word list from NLTK you can check in the next slide. As you can see here, some negated words like isn't, on, not are included in the list. This negated word can be very important feature in case you want to analyze the sentiment or complaint from writer for your target, depends on your target model. Thus, I recommend you should carefully check what you are removing in your analysis context. So in this example, you can check the not and these kind of word were removed after stop word removing. Okay, the punctuation also means the characters which can be considered as a source of noise, such as apostrophe, comma, or the bracket, etc. You can observe here that the square bracket, question mark, were removed. I actually gave the punctuation list which should be removed using regular expression here. So the double apostrophe here were not removed as it's not in the list. Okay, finally, part of speech tagging means the process of marking up a word in a text as corresponding to a particular part of speech based on both its definition and its context, like noun, verb, adjective. It can be helpful because POS is telling more clue about the roles of each word in the given text context. Usually in a sentence, noun and verb words can tell you more critical information than the prepositions or interjection word. And you can utilize these information as the part of picture for your further modeling process. Okay, in this example, you can check the results of POS tagging using Spacy here. In this session, we will talk about the more advanced NLP topic, which is word representation and word embedding. Before we go there, we need to understand the terminology of corpus first, as our further training or further analysis background will be really closely bound to the scope of your corpus. Corpus means a collected language resource of a large and structured set of text or documents. You just can think Wikipedia would be a good example of corpus, and actually many companies like Google or Facebook are utilizing this as one of their NLP research and development resources. Okay, then, what is word representations? Simply put, it is the way you feed your text data into a machine-readable format, and the vast majority of rule-based and statistical NLP tasks regards words as atomic symbols. So you can enumerate all the words in your corpus as one vector. We call this as bag of word. And you can describe each text document with a binary encoding of each word existence. We call this, in this case, as one-hot encoding. From there, researchers have been studying a lot the way to more well describe this text document with a vector. So its initial results are term frequency representation, also known as counter vectorization method, and TF-IDF representation. TF representation is simple. It's just the term frequency of each word instead using the binary encoding of word presence. So in this example, for the document 0, the word of king presence once, so the vector value of word king become 1, while for the document 1, the word of king presence twice, so the vector value of the word become 2. You can easily test this method using tools like sklearn or gensim. This is the use case with sklearn. TF-IDF tried to reflect the importance of the word in the corpus by multiplying TF with IDF. So the importance of common words such as A, D, etc. across the corpus can be lower-weighted in this function. You also can test this using the same tool. However, these kinds of traditional word representation methods have the problem that there is no way to reflect similarity between words because they treated a word as atomic unit. So the concept of word embedding has emerged. The word embedding is a distributional similarity-based representation method by learning the relational meaning with neighbor word over word using neural network. Therefore, the word-to-back, globe, FastText, all of those are in the word embedding methodology group. The basic idea of learning neural network word embedding is define a model aiming to predict between a center word and its context word in terms of word vector, and keep adjusting the vector representation of word to minimize this loss function. Okay, then let's see the well-known word embedding method, word-to-back. Word-to-back has two algorithms. One is sklearn to predict context word based on a given target word, and the other is continuous back of word algorithm to predict target word from the back of word context. You give the window size of context word like 2 or 10, depending on your corpus domain. As a result, you can earn the trained vector value for each word, and they can reflect some similarity between words, like this example in this graph here. So you can find some similarity between the man and woman, and king and queen, something like that. You also can test this method using gensim or the other tools. In this example, I just extract the vector value of one word, which is easy, from the pre-trained vectors using word-to-back algorithm based on Google News corpus here. In the next example, you can see how to check the similarity between words using the same tool here. So you can see you can find the most similar word with the women and queen positively. Meanwhile, it's negative. It's far away from the man word. The FastText is an extended technique of word-to-back proposed by Facebook in 2016. This algorithm feeds several n-gram, which is subwords of individual words, into the neural network. For example, you feed F, PPL, and PLE instead of one word of apple. It is reported that FastText can handle out-of-vocabulary words much better than the word-to-back, and it's useful when you don't have enough big size of corpus. In this small size corpus training example, you can check that FastText show better similarity result than the word-to-back. Here, when you give the query the similarity between the boy and the boys. Finally, we left the one last session, which is topic modeling. Topic modeling means a technique to extract topics or concepts based on the pictures from text documents, which allows for us to analyze large volumes of text by clustering documents into topics. This is one of the unsupervised learning methods. It is useful technology when you have an enormous volume of text or document resources, including important insight, such as knowledge systems, and you need to cluster and classify them automatically in a more useful way. The most well-known algorithm in topic modeling is LDA. Its full name is Latent Dirichlet analysis, which is a generative probabilistic model where each document consists of a combination of several topics, and each term or word can be assigned to a specific topic. Each latent topic contains a Dirichlet prior over them, as it's based on the Dirichlet probability. You have to decide the number of topics as its model parameter, and it often gives a big influence on the coherence results of the word from each topic. You can test this LDA method using GenSim also. GenSim is a really good tool for this LDA as it's providing different kind of LDA algorithms such as hierarchical LDA, Merlot LDA, as well as plain LDA. When you set the LDA model parameter like this code here and run it based on your corpus, then you can earn an LDA model like the next slide, which is expressing each topic with the keywords and their weights. Based on the in this example, when you look at the topic 0, you can observe the every keyword here, related keyword, and the weights according to each word. Okay, based on the above model results, we can get some idea how this model is describing a topic with each related keyword, like this figure. And here, the car, power, lights, drive, this kind of word describing this automobile topic. And the good evidence Christians believe this kind of words are describing this religion topic. One of the really useful thing of this LEA algorithm, you can check the performance of your model with the metrics of perplexity and coherence score. And you can try to adjust or optimize your topic model based on those metrics. In my experience, especially the coherence score was useful to find the optimal number of topics. In a recent research field, this topic modeling methodology is evolving also by trying to embrace the benefits of pre-trained neural network language models like BERT. So the contextualized topic models become a new innovative approach in this NLP category, NLP task category. In this approach, it's good that you also can utilize the visualization tool of Pi LDA, like traditional LDA, as you see in this figure. I just mentioned this new approach to let you know the technical trend in this NLP task category, so I will not go further for the detail of this approach here and recommend to check the paper or its GitHub repository if you are more interested in this topic. Okay, then let's call it today. Thank you for listening my talk session. Hopefully I can meet you guys in person in the next opportunity. All right then, have a good day everyone. Bye.